So let's go over the practice final first, or the one that has all the blank spots, and then we'll go over the final one, the actual final one. I'll talk about what I'm going to do differently. The only thing I'm going to do differently is to make it easier for you guys. Well, in my opinion, it's easier. Whether or not you think it's easier is up to interpretation. What I'm going to do is I'm going to make fewer ambiguous answers for the multiple choice. That's all I'm doing. Yeah, no problem. So let's look at these guys. Write a function that returns an array or array-like structure that contains the even elements from 2 to 100 inclusive. Your function should take no arguments and be called evenness. When we look at this, and we look at the C or the C++ function, we know that there's going to be a return type. What is the return type for this function? It's going to be an integer what? An array of some kind, which is also an integer pointer. So we're going to have an integer pointer, which is going to be returned. How many elements are there going to be? 50, right? Because 2 to 100, there's a 50 elements there that are even. It's not 51 because we don't include 0. So you have to, in C, you have to know how to do the return type. So you know that your return type is going to be something like this. You're going to do int star, evens, takes no arguments. You're going to have your int star vals, I don't know what you call it. And then I'm going to typecast this as an int star. I'm going to malloc some space. The amount of space I'm going to malloc is going to be 50 times the size of an int, which is 4 in this case, and I just ran out of space, but that is going to be size of int, like so, inside of that. If you chose to do this in C++, you could also do an int star there, and you could say int array vals equals new int of 50 as well. I believe that'll work in C++. That won't work in C#. Either one of those lines are essentially identical. You could also have an int star like so. This, however, doesn't work in C, but since it says C or C++, if that's what you've written, I would have given full credit for that. Once you do that, then you have to fill full values. So you have some sort of for loop for int I equals 2. Hello. I is less than or equal to 100. I plus equals 2. Actually, let's do this way. I equals 0, less than 50, I plus plus. That's the easier way. And you can say vals, because I forgot we had to do the index of I, equals I plus 1 times 2. Return vals. That's the full credit or something along those lines answer. If you screwed up the loop a little bit, if you forgot, first of all, if you forgot syntax, just syntax, no points. Like if you forgot a semicolon, no points off, those kind of things. If you screwed up the loop boundaries, like you said 0 to 100, unless you did some special indexing inside the vals here, like you say vals divided by I divided by 2, or something like that. There's a couple different correct ways to do it. If you're screwing something up major, the syntax would be mostly correct. If you did not use a malloc, that would be a somewhat correct, or a new. If you instead tried to do the operator, if you instead try to do this, int vals of 50, that's only worth half credit, because that's demonstrating, this is what the question is asking you, is that this is not an array that I can pass back. I cannot pass the black array here back. I can pass the blue array however I can. Why can I not pass the black array back? Because it's on the stack, and the stack goes away after the function ends. You need to know that. You need to demonstrate that knowledge. That's actually the only point of this question is to ask you that in C. And then whether or not you know Lua syntax. Because you can't get that. Essentially, if you do the same exact thing in Lua, you have the same exact functions with some minor differences, you have the correct function in Lua. Same thing is true in Python and the other languages. Haskell, I'm more not going to talk Haskell's super easy, actually, just dot by 2. It's okay. This is what the question is asking, the difference between those two things. Most important part. Know your Lua syntax. Does anyone want to see me do this in Lua?
Yes.
Yeah? All right. I'm going to do this one on Notepad++ just because I can. So assuming that it's installed. It is not. What if REPL has it?
Claro, tonto.
Actually, REPL, this is a brand new thing. This is the first time I ever saw it. I discovered it in class that they were looking for Python.
Did you?
Possible.
Hopefully somebody else does.
Fuck off.
Function.
Y lastimado, eh?
Evens takes no arguments. This is not Python. And you could either, so it doesn't matter if you could declare this local or not, but I would have preferred it if you did. I don't remember if 50 is the right answer, but there you go. Vowels. Oh. It's a table. That's the idea. Same exact thing, almost the same exact loop. You just have to know Lewis and Lewis syntax. So you know the common syntax for Lua. Python, pretty similar as well. Might actually see if I can integrate this with it. Because there's a way that there's a way that I can get all my students to turn all their assignments into using REPL, which would be cool for this class. Same idea, but you know that you use def instead of function. You know that you use tabs instead, so it's you can do the same thing. Vowels equals it's a list for I in range from 1 to 50. Vowels of I equals I times 2. Return vowels. Oh, I forgot to return to Lua. That's what I was doing. Return vowels. That's it. Next range. Oh, I'll do this then. I would have given full credit for the list one that way as well. Either one would have been fine. There's also in Python, if you want to do a list comprehension, you can do a list comprehension. X in, or you could also do just a range. You could just say range of 2, 50 by 2. That's also that's 100% correct answer, even though on this one here it doesn't. It just shows up to that. Yeah.
Why did you have to do curly brackets for vowels for that to work?
I don't know. I screwed up something, but that one should still work now. Yeah. So I didn't get quite 100, but that's okay. If you wanted to use the range function, so that range function right there. So on the midterm or on the final, sorry, if you had answered range 252, you would have gotten 100% correct answer for that, because that's Python. Lua doesn't have that functionality. If you had done something like this in Python as well, it would have also been fine. Obviously, we don't have the last one, so 2 to 51. But I'm not expecting you to remember that 50-51 issue with the inclusive exclusive on the end. Both of those are acceptable answers. Haskell is pretty similar. It's just a dot operator. Questions about this, or that, or Lua?
What's going on here?
Which one?
Just when you said evens and you called the function and saying, oh, double of 1 is 2, double of 2 is
So index 1 is 2, index 2 is 4. Because it's a dictionary. So this is a dictionary, not a list, which is the difference between a dictionary and a list. Dictionaries can have anything as their values. So like for example, if I wanted to turn this into a string, I could turn this into strings. Didn't like that, but that's the idea. There's nothing in it apparently. Oh no, there we go. You can use strings instead of. You can see how the key is 15 instead of the other part of. I don't know why it started at 15. That's kind of strange. That's the basic idea for the first question. So essentially it is, do you know the syntax for the languages we talked about? Do you know some of the built-in functions? Can you approximate an answer in a short period of time without assistance? That's it. And so even if you had gotten one of those other ones that didn't run right away the first time, still 100% correct answer. So long as you get the basics down. If you're missing something significant, then that's a problem. If you wrote the for loop in Python as a C for loop, mostly correct, so on and so forth. Number 2, how does a programming language get transformed from a series of consecutive strings in the executing program? Primary steps are...
Tokenize? GFC? Evaluate?
Yeah, so tokenize, context-free grammar, or parse, and evaluate, or code emitter. What is the purpose of the tokenizer?
Split?
To split the string into the component, or to the smallest potential parts. And so we don't know that they have meaning, but it's the smallest part that might have meaning. Step 2 is to figure out if the grammar is conceptually valid or not. Are the sentences constructed grammatically correct? If they're not grammatically correct, we throw them out. Humans are able to understand sentences that are not grammatically correct. We did that example where we said things like, Billy kicked the ball red. And we're like, okay, we could probably fix that. Programming languages do not do that fixing for you. Third step is the evaluator. That's where we actually discover the values of variables, or whether or not the parts actually have semantic meaning. For example, the sentence print x. I said, hey, our sentence is print x. You're like, yeah, that makes sense for Python and reload and stuff like that. Well, if x doesn't have a value, that doesn't necessarily mean it can work, because x might not have a value. If x has no value, then you can't necessarily print it. Lua gets around that obstacle where if x doesn't have a value, it prints out the value of nil, because nothingness is a value in Lua, or the lack of a value is a value, which is counterintuitive. That's what we're talking about here. Does anyone have a question about... so how do we accomplish each one? So how do we accomplish tokenization? So what tokenization is the separation of the string into the smallest composite chunks of strings. How do we do that? We split the string based on a delimiter, right? There's a function in Bash, not Bash, it's not even a function. There's a program in Unix that is good at splitting things on delimiters. What's that function called? Cut, right? Cut does a pretty good job of that. The only thing it doesn't really cut on is new lines, but such is life. So cut would be a fairly good tokenizer except for the new line part. Step 2, how do we accomplish parsing?
I have a question for step 1.
Yeah.
Do we have to consider that there's always going to be one variable, assuming there always is?
There's always going to be delimiters. And so if there are no delimiters, then your smallest conceptual chunk is the entire input string. Then the tokenization is correct. Kind of like if in Python, for example, if I go to the Python guy here, and I say x equals 3, I only have to type x, and x is the smallest valid chunk, and it returns the value 3 in this case.
We don't have to consider the case where someone would type x equals 3 without spaces.
We don't have to think about how we would accomplish that. We know that they're delimiters. The fact that the equal sign is a delimiter isn't important. It's just that there are delimiters. Good question. So it's not just we're not just splitting out spaces. It's just in general the word delimiters. So that's actually a good point. So she was saying, hey, what if what if I say just splitting on spaces? That's incorrect. You want to if you use the word delimiter, that considers everything that might be something you need to split up. And so it's kind of that catch-all term. Okay. How do we accomplish step 2? Context-free grammars or parsers. How do we accomplish that? So the grammar rules, right? And what do we do with those grammar rules? What do we build? But how? What is the method by which we can verify that a sentence is constructible or not? What do we build?
The interpreter?
Well, the interpreter runs it. That's not the part that's doing it. So there's the set of rules. What do we do with that set of rules? Say that word louder. Say that word louder again. You build a tree. If a tree can be constructed that generates that sentence, the sentence is grammatically correct. That's what we do. We build trees. That's what context-free grammars are. So the grammar trees are what we're looking for. Step 3. I'm not going to ask you step 3. we haven't really gotten to how evaluators work. We started to write an evaluator to some extent, but really we kind of cheaped out by using Python's evaluator. We won't really get into evaluators. I won't ask you. Object-oriented programming. So we didn't discuss C++ a whole lot, but hopefully you guys can do that in Java instead. It's essentially the same. Not essentially. It's the same idea. I'm not going to ask you to do a C++ object on the test though. So I might ask you to do a Lua object, and I will ask you to do a Python object. In the class, we've discussed object-oriented programming, the purpose and varying methods. Define appropriate object-oriented programming elements necessary for you to be able to instantiate the thermostat objects. In each of the languages specified, each thermostat object should have a single member variable called temp, which hold whole numbers only, and that will set the temperature member variable, or a constructor that sets the member temperature variable, and a getTemp function that will return the member temperature variable. Okay, let's do those. Let me get a new rep for C++. Pretty sure they have one. We don't have a C++ one here.
When you say that we set the temperature, do you
There's
mean
the constructor. Yeah, initial set.
specific value or take a value?
It'll take a value. So the constructor will set the temperature variable and it will take a value. If it's, So you don't actually have to do any of this part. All you have to do is define the class. Is it called thermometer? Thermostat. The thermostat class. After defining a class, you know whatever. Private int temp. Two publics. Public, which is the constructor. The constructor for classes has the same name as the class, like so. And we also have the getTemp function, like so. If you define the class this way, I'm going to real quick show you. If you're not familiar with this, again, I'm not going to ask it on the final, but if you are kind of familiar with it, then you get the idea. You can define the function outside in C++ like so. have to do the return type. If you don't do so, if you define a constructor that takes an argument and you don't define a default constructor, it eliminates the ability to call the default constructor by default. You can no longer call it. This is one way to write it. If you didn't want to write it as two different parts, you could also write it up here. There's no reason why you can't do this. In C++, allows you to write it like this. Both of those are correct answers for C++. Either one's acceptable. Similar to Java, the only difference is that Java you have to write the public on each one of the function calls and private on each one of the member variables. In Python, do something like this.
Thermostat.
Do I want to put the temp variable here in Python?
No.
So I had somebody say no. Can somebody else tell me why not? So in C++ and in Java, this temporary variable here is a member variable for the objects, whereas in Python, this variable, if I define it here, say temp equals 3, does that depend upon?
It's for the class, right?
That's for the class. This is a static class variable, not a member variable in the objects. So if I go on, so if I define the init function, that's the answer for Python. Relatively straightforward. The self reference is mandatory as the first argument in Python, whereas the self reference is not required, nor can you define it in C++ or in Java. You have to, it's the implicit, so for example, when I use this reference here and here, in Java, those references are implicit and you cannot define them. In Python, they're mandatory. Yes?
In the C++ version,
Yep.
do you need an inline keyword? No. What's the inline keyword?
Inline keyword does not need to be used ever anymore.
Really? Is it-
You are not smart enough to use it. It's not that you're not smart enough, it's that we aren't as humans using it anymore. The compiler is the only thing that does the inline. The compiler ignores it for the most part. Everything after GCC4 has ignored the inline keyword almost completely. They introduced a flag called force inline, which forces the programmer's use of inline, not the compiler's use of inline. And almost 100% across the board results in slower code.
Okay.
That's something from ages past. Nobody actually uses it anymore. All right, so the Lua version. The Lua version is the one that requires a little bit more work. In the Lua version, you have to make sure that you have some sort of So this is the part where in the question it says appropriate object-oriented elements necessary for you to be able to instantiate a thermostat object. That's because Lua doesn't have the object-oriented programming parts necessary for you to do this. And so you have to be able to define the new function for temperature. With the set metatable function in it. Like so. And then you can define the other, so the constructor here, T. Change this to option. Forgot to set the memory variable. So you have to define your constructor in Lua in a special way. If you decided to define the constructor for objects first and then make a temperature a child of object, that also works. There's a couple of different ways to do this, but if you wanted to force the declaration of the self variable, you could also force the declaration of the self variable using the dot operator instead of the colon operator. Okay. Questions? Yeah.
When you say temperature, do you mean thermostat?
Yeah. Absolutely. Thank you very much. Let me go copy that. I called it temperature over here too, didn't I? There we go. I'll copy it there. There we go. Better? Thank you very much. I appreciate that. So what's the question asking here? Besides, do you know some syntax for several different languages? So the question is, what is object-oriented programming and which languages give it to you and what does it mean in different ones? So do you know the difference for Python versus C++ is, do you know the difference between member variables and static variables? For Lua, do you know what it means to have the self-reference versus the colon operator to give the self-reference to you for free? Because you don't have to write it this way, but if you write it this way, it's also the correct answer. You have to know about the colon operator to get away from it. In Lua, do you understand how the set meta table gives you the object-oriented programming techniques, and what does that mean? And so how do we know that that gives us object-oriented programming? And then that tells you about Python, and that informs you about how C++ works. C++ doesn't use tables. C does use tables. They use this thing called a virtual function table, and the virtual function table is how all stuff happens inside of C++. It's almost, once you learn how Lua and Python do it, the rest of the languages, they just kind of fall into how those two do it, but with slight differences. But that's basically the idea. Other questions? Yeah?
You mind flashing back to the
Yep. I'm not asking you to know a lot about specific languages. It might seem like I am asking you to know a lot about specific languages, but I'm not. What I'm asking you to know is the surface layer of specific languages with a lot about programming. That's what I'm asking. So the question here is not about can you program object-oriented programming in Python. That's only a secondary question. The question is what is object-oriented programming and how is Python and C++ different? And you can demonstrate that by the way that you write it. If you're incapable of writing this, then you must not know the difference between C++ and Python. Because the syntax is not significantly different. That's the big problem. Lua is the one where you have to now memorize some things, because you have to memorize things about object-oriented programming in a couple of keywords that is specific to Lua, which is specifically the set meta table. If you didn't do the self.index, I wouldn't have docked you any points because that's not important for us. It would actually still work. The only time you need the self.index is when you have inheritance. If you did this, it'd still be correct. Yes?
Now, when you look at the C++ version, is it better to do the first version that you did, where you define thermostat, or the constructor and the get temp outside, or is it better to do it inside the public version?
Mostly, probably 9 times out of 10, it's going to be better to do it outside. That doesn't mean you can't do it inside. And I don't know how much of that is the way the compiler works for C++, which is different than the way other compilers work. or how much of it is a holdover of the way C headers worked because we didn't have Google and you didn't have web pages that you could go look at the C headers. You just had a book of all the headers. And what you were doing is you had a book of all the headers, and you would flip to a page, and you'd look at all, and you'd be like, oh, okay, these are all the headers. And you didn't want all the headers to be confused with all the code, and that doesn't matter anymore because we have the tools available to us. And so, for example, if I did this with the thermostat stuff before, like this. I can ignore the implementation and just look at the header declaration. And so in the past, this was important because I had to print this shit. And that's not true anymore. Like if you look at Java, you look at C#, you look at every other object-oriented programming language, they don't care. But it might have something to do with the fact that the C++ precompiled preprocessor actually pulls the text from this file into other files, and it might make it larger. So it might be better to do it this way, but I'm not positive that's true anymore, particularly C++. So it might just be convention. I'm going to say 9 times out of 10 outside, but otherwise I don't know why. Is a good answer. I used to know why, but I don't know why anymore. Technology's changed. Does that answer your question? Maybe not sufficiently, but other questions? So this is the complete one. The other one. Okay. Next one. Object-oriented programming. Consider the differences between various object-oriented programming implementations. How many parameters do constructors take in Python 3? In Problem 3, sorry, not Python. How many arguments do they take? 2. Those two arguments are the self-reference and the temperature reference, right? In C++, do you see the self-reference or this reference? No. Does it mean that it's not there? No, you can still use it. You just don't see it. Does object-oriented approach used by Lua offer the same protections as C++?
No.
Or the same protections as Java? The answer should be no, and you should be able to tell me why. The hint should be the word protections.
Lua doesn't actually use any protections.
Like, what does that mean?
So, yeah, there are no access.
No access specifiers. There's no private, public, protected, right? Python is the same way. There's no public, private, protected in Python. You can implement public, private, protected in Lua. It's just a pain in the ass. Prove it there's no public, private, protected. Is there another reason? There might be, but that's the big one. Ignoring the fact that C++ exists, what would be the first step in turning C into an object-oriented programming language? Use structs. And what would you put inside of the structs? Variables and methods. Those are the two things you put inside those structs. In what ways would this object-oriented programming in C be similar to Lua? There's no access specifiers. Lua essentially is a table full of data and methods, right? Which is essentially what a struct is. Are there other parts? That would be good enough. You can write those two, those would be good enough. In what ways would it be incomplete? We don't have inheritance, we don't have polymorphism, we don't have those other parts. In Lua, we can do the same thing, but we get inheritance and polymorphism through the metatable functionality, which we don't have in C++. So if you instead of here and say, well, how would you do this? You'd have to say, well, let's get structs and some form of meta table functionality. Then you can do object-oriented programming. And the way that C goes to C++ is they implement meta table functionality through the use of a virtual function table. That's what they call it. That's what that's the magic domain. Why do larger organizations prefer to use class-based object-oriented programming? So I said class-based here, not prototype-based. Lua is a prototype-based language, so a class-based object-oriented programming language with built-in protection mechanisms. So not like Python, but something that has public, private, and protected. Why do they like this? It allows you to work in teams more easily. Why does it allow you to work in teams more easily? Because somebody else can't screw up your code. Nobody else gets to touch your privates. Stay away from each other. There's a whole HR thing on that, which recent research says doesn't work. So, who knows? Programming paradigms. Imperative. You do it without reading it. Ah, shit. What do we have to do before the test? So imperative is what is written is what is run. What is declarative? What you want, not how to do it. You're right. Which is another way to say it, what you're doing, I guess. That'd be okay. I'll give you credit for that. What you want, not how to do it. That's how I would say it. Structured. Say it louder. Like,
if statements, brackets,
so classes actually isn't part of structure. That's part of the object-oriented one down there. But you're on the right idea. Anytime that you have easily definable scope is really what structure is. Procedural. Correct, and it's not really just about built-in sub-procedures. It's the ability to call sub-procedures or sub-functions or something like that. Almost every language is procedural in some way. Functional. Sorry?
Mutable variables.
No mutable variables. That doesn't really help me though. Okay, that's true.
Pascal.
That's the next page. We're almost there. So functional languages are built around the composition of functions. So combining multiple small functions into a larger function to build on functionality. We do that same concept with procedural programming, but it's not the same. It's instead of composition of functions, it's the iterative calling through imperative use of functions in other languages. Object-oriented, logical. Yeah.
Can you give a simplified version of what you said
For
functionality?
For functional?
Yeah, functional.
A language designed around the concept of compositional functions or composition of functions. To build larger functional structures. And a function it has no mutable. The other part of that is a function has no mutable variables, or and does not modify state, global state. This gives you the independency that function calls are independent of each other, which allows you to run them in parallel. Logic or logical. So it applies rules to data to allow you to learn more information or relationship between those data points. These are also called expert systems in other languages. So like if you want to use an expert system in Java, essentially what you're doing is you are calling a logical language, or you're using a logical language within Java. Which of these does Python support? So essentially, is Python logical? No. Is Python object-oriented? Yes. Is Python functional? No. We have list comprehensions, which is close to functional, but it's not. The difference is that Python list comprehensions can modify state. Procedural. It can call functions in Python. Structured, as if statements. Declarative. Remember what declarative means, right? No. Imperative? Yes. And so when you come up to a new language, you learn about a new language, you're like, oh, the new language is imperative structured procedural language. You're like, oh, so it's like C or Python. Is it object-oriented? Oh, so it's really like Python and C++, or Python and Java, or some other language. Oh, this language is functional, so that means it's like Haskell, or something along those lines. It's not like, I can't say int x equals 3 in this language if it's a function. Yeah, I get that. Declarative is something like SQL, and once you learn about SQL and you start using SQL more in depth, you'll go, oh, it's a language where I ask for things and it just gives me stuff when I ask for it, instead of declaring declaring what to do. So really, the big difference between imperative and declarative is you write the steps, not what you want. Declarative is you write what you want, not the steps. They're the two sides to the same coin. Other questions? Yeah.
What makes something like SQL not just a program and instead a language?
So a lot of times people talk about like things like that as just programs, and a lot of and yes, they are. They can be. Like we talk about Excel as being a language because we can program in Excel, and a lot of the things that we program in Excel are declarative. They're not imperative in Excel. Excel is kind of what we call a fourth level language. It's kind of like it's higher level than C and C++ than Python because it's more available to non-programmers typically. But oftentimes when you talk to people who use these languages, they don't talk about it as if they're programming. They just talk about it as using an application like Excel. You know, there's always going to be that guy at the office eventually, wherever you work, who's going to know how to use pivot tables in Excel, and you're like, how the fuck did you do that? That's amazing. And you're like, that would have taken me 6 hours programming. And you're like, yeah, I did it in 4 minutes. You're like, shit, I need to learn how to do that. And that's one of those powers with declarative languages. And people who don't think they program can do amazing things because they're not programming, they're just asking for what they want, and then the Excel figures out how to give it to them.
So the answer is not really a language.
We call it a language because it's still a set of symbols that we write that is parsed in the same way.
I was going to say it is, I think it's C++ right now.
Yeah.
And you're pretty much telling your computer using words what you want, and it's giving you back database entries.
Yeah, it's kind of like, and so if we think about, as for example, let's suppose that this over here, let's clear this. This is Python. This is Python 3. That terminal over there is a computer that I have access to, and I can ask it for things. I can say, hey, what is the value of x? How do I ask it to look for the value of x? I say print x in this case. Well, I don't have the value of x. I can say x equals 3. Then I can say print x. And that'll print the value of x in Python. In other languages like SQL, I can ask for the value of x in a different way. And then the way that you're doing it is usually you're not asking for a single value, you're usually asking for a lot of things with relations. You say like, give me all of the people who are over 5 feet tall and under 6 feet tall and weigh more than 200 pounds, put them into a category of overweight. And there's a way that you can write that. You say in SQL, you're just using English words to ask for things, as opposed to, it's the same concept, but just a little bit different. The approach is backwards from the way programmers think. There's a database administration is the high paying job. Does that answer? Kind of? Other questions before I move on? Sorry. That was good. Functional, yes.
I remember you mentioning passwords, WYSIWYG, which one of the
WYSIWYG,
paradigms
say
was
that? Yeah.
Yeah, was one of the paradigms WYSIWYG or?
No. No. WYSIWYG, do you know what WYSIWYG means? What you see is what you get. That's not a programming paradigm, that's usually a design paradigm. WYSIWYG is usually easier to do with things that are declarative languages because you can organize them. It's easier to organize that way. Functional programming. Complete the following sentences. Functional languages have no mutable variables. Functional languages have no side effects. Functional languages can pass functions to other functions as parameters. This is known as first order languages, first order functions, or first class functions. It's independency. A and B make independency. C makes first order or first class functions. The primary benefit is parallelism. But actually, explicitly massively parallel. Lambda. I don't think we've talked about lambda. So let's do it now. Does anyone know what lambda is? Say again? No.
Like a lambda calculus.
So what is lambda calculus?
Type of way to operate.
Okay. How?
All I know is you do one thing at a time, and once it's completed, you go on to the next thing.
So yes, lambda calculus is where we get the name for it. But the big part about it is lambdas and lambda calculuses are unnamed functions operating on data independently of each other, which is essentially lambda calculus is functional programming with unnamed functions. Using unnamed functions. Some languages, functional languages in particular, use lambdas a lot, but some languages provide lambdas more easily than others. The language that is probably most commonly used in industry and everywhere else is C# that supports lambdas. Java just implemented lambdas with Java 8 was the first time they did it. They implement it using the concept they call delegates. So if you've heard of the concept of delegates, delegates are the same concept of lambdas. Delegate. These concepts make graphical user interface programming exceptionally simple. Without delegates or lambdas, user interface programming is a pain in the ass. It's not that you don't have names for, so it is about unnamed functions. But it's not that you don't have names for the functions. It's that the functions can be renamed essentially at will. So if, for example, do I have Visual Studio on here? Be the easiest way to show. Okay. Let's suppose that you have a form on your page, on your application. And in your application you have a button, and this button says click. Sometimes that button does one thing, sometimes that button does something else. So for example, if you're doing a payment processing, when they press the button click the first time, it should try to process the payment. If they press that button again, should it try again to process the payment? No, you don't want to try to double process payments. So you want to have a button that does multiple things. And so what we do is we attach a function variable or a member variable to this function. So let's say this is the onClick function. But this onClick function can be other functions. And so for example, we could have the payment process function over here. And we could have the notify user to wait function. Those are the two different things that it can do. And depending on other state of the program or other states of the program, the onClick chooses one of these two functions. Both of those functions do different things. Neither of these functions have their own name. They're both known by the same name onClick, even though there's two functions with the same name. How do I determine which one's functioning, which one's running? It depends upon other state variables, but that's essentially the idea. That's how we use it in user interface programming. So it's an unnamed function that allows you to do these things. C# implements this in something called LEAP, which allows you to do one-line instructions that would take you hundreds of lines of C or C++ code in a single line. They're very powerful. This is one example of where you would use them. List comprehensions are another example of lambda functions. When we write that list comprehension, just erase what I had here. When we write this list comprehension in Python, in here, this isn't a lambda. The whole thing is a lambda. It's an unnamed function. We call that unnamed function, we execute it, we see what we did, we get the results, we store it inside of a list. So for this problem, we want to know the three parts. What are the three parts of the lambda? Say that again? So the function to apply, variable declarations, variables available, and over here, this last one is the data source. When you look at a function is a name with some parameters, right? In this list comprehension, we have some variables as the parameters. We have the function we're going to apply to it, which would be the function body of the function, and the data source is where we get the data when we call the function. So we declare the lambda and we call it all in the same line. That's one example of how lambdas are powerful as well. Why do we want to know how to use them? So parallelism is one answer, but there's another answer that's probably even better than parallelism. Simplicity. We can simplify our code. Instead of having a long chunk of code, we can simplify into a single short line that we can write a comment that describes what it does so that we don't have to worry about that. And so we have shorter code that results in easier to read code. Other questions? Other questions about this test, or this practice test?
Kind of about language, so you went into those comprehensions while still talking about language, so that still applies.
Yeah.
And would that kind of be similar to how we use grades for
In Bash?
are we doing any Bash?
I don't believe so. Did I ask you any Bash questions in the then no, we're not doing any Bash. If for some reason there's a question that says use any language you like and you want to use Bash, go for it. But you don't have to specifically remember Bash. Although I hope that you've learned some Bash because Bash is super fucking useful. Good question. Yeah. It is the same kind of concept.
We do stuff inside stuff.
Yeah. Okay. Questions about the multiple choice? They don't have questions about what's the correct answers because we went over some of these. Where did we stop? We stopped. I think we did them all. Huh?
We did them all.
We did them all. All right. So let's look at the free response. Why do large organizations prefer oh, hey, neat. Okay. I probably won't ask this question again as free response. So you should know the answer to this. Why do you think you should know the answer to this free response question?
Because it can be multiple choice.
Because it probably is going to show up as something like a multiple choice question. What should you remember about the multiple choice questions? Ah, neat. That makes it really easy to write tests. If you didn't know that about tests, now you do. Which programming paradigms does C support? A? What did you say? The words. Imperative. Structured, procedural. No. It's not object-oriented. Okay. If those are the only 3 you wrote, you got full credit for that. Strict typing is not a programming mechanism. Sorry, paradigm. 3. What mechanism does C lack that object-oriented programming languages support? Object-oriented programming, which is polymorphism,
Inheritance.
access specifiers. Okay, good. Sometimes people come up with that sounds good. What object-oriented programming mechanisms does Lua lack? Access specifiers. Anything else? If you want to be specific, you can say things like, actually, no, you can't say those things. What's the difference between dynamic typing and strict typing? So you're right. So the idea is that either the variable has the type or the data has the type. So when the variable has the type, the data inside of it is the type of that variable. When the data has the type, the variable that contains it doesn't matter. The data carries the type around with it. That's the big difference between the two of them. In C, for example, C is strictly typed. I can put a float inside of an integer. When I do that, what happens to the float? We interpret that float as an integer. We interpret those binary bits as an integer. I cannot do that in languages like Python. There might be a way they might have functionality that allows you to do that, but it's not built in by default. It's not the built-in language. Here's some functions, write some functions, real valued average. I think we did this one already. Do you guys want me to write these? Yes? No? Don't care? Somebody say yes? Yes? Okay. All right. Okay. Well, let me look at the other questions before we start doing this one. Object-oriented components. Oh, we did this one in class. We did this one. Oh. Okay. Okay. Oh, is there one more? Oh, extra credit. Okay, so let's answer the extra credit before I answer the other, because those will take a little bit longer. Why do we use context-free grammar for parsing? Okay, I'll give you half credit for that. Better, but you're missing. So can you take it and convert it into a sentence that means something in English? So you said context-free grammars can determine correctness before execution, right? That is why we use context-free grammars. what does that mean in English words that isn't what he said?
Determines if the sentence is syntactically accurate
Without,
without semantics.
correct. Why? So can you say it even simpler than that?
The structure is right, even if the meaning is
Correct. Regardless of the meaning, we can tell if the structure is correct. That's why we use context-free grammars. That's actually the definition, context-free grammar. Without context, without semantics, without meaning, we can tell if grammar is correct or the structure of the language is correct. That's why we use context-free grammars. Because we don't have to know the values of it, particularly for things like compiled languages. I don't know the value of X yet. The user hasn't typed it. What mechanisms provide object-oriented programming functionality in Lua? Metatables. How do they work? It's information about information, about itself. Okay, but what else? How do they work? Okay, close, better. There, that's the one. So if you don't know the information about something, you can look at your metatable to find information about that thing. That's the idea. It's also the way Python works in C++. Considering the existing set of programming paradigms, provide a novel paradigm that would benefit you in building an application. Doesn't have to be practical. Someone come up with a programming paradigm. I gave credit. I gave this to everybody. If anybody wrote anything down on this one, I just gave them full credit on this because nobody came up with very good stuff. Can anyone come up with a new paradigm? The best one was write my shit for me. That was what I gave. Most people did. What do you mean?
Can be used in different programming languages?
So that's the wrong way to think about it. So languages implement paradigms. Paradigms don't implement languages. But that's a good guess, though. Good go.
Plain English parser, so you write like what you want the program to do, and it interprets it.
That's what declarative languages are. You write what you want, not how to do it.
Except without any specific syntax. It's just a sentence.
Well, then you're just defining a declarative programming language. See why it's hard? Just give it a guess. That's okay. Write a Python function that determines if the whole number argument is prime or not. So this is if you know how to write prime numbers. Write a primality test using list comprehensions in Python or Haskell. I did that last week. Okay, so let's go look at those other two questions. AI writes my own programs, and I still get paid. That was in parentheses. Artificial intelligence programming writes my programs, I get paid. Write a function that finds the real valued average of its argument array of real valued elements. So in C or C++. Yeah, I'm going to post these, I guess. But I'll do it now anyways. I got a couple minutes. What is it called? It doesn't say anything. It doesn't say. So that would be C++ or C. There's actually a C++ 11 way to do this in a single line, which is kind of cool. But that's new C++. It's newer than I am. I don't know what to do. I'll learn it eventually. Just more shit to know. It's the problem with programming languages. There's always more shit to know. Python. Function called length in Python does this. You could also do the other version that is common. Looks like this. So another one that's common. I think you can do it in list comprehension too. You just return the single value. And any other questions about those two for Python? Sums. Lua? This is the most complete version. That's the most complete version. A shorter but also complete full credit version would be this. Pound vowels. Lua has pound vowels. Pound means number of, count of. The problem is that Lua does not require that its lists or its tables be in order. And so if these are not in order, then that average function wouldn't work. So for example, in Lua, if I have the table T equals 1, 2, 3, 4, like so, that's the wrong table. Wrong language. So if we have the table 1, 2, 3, and 4 like so, if I called average, I'm going to be using the second one. Let's call this average 2. So, and I call average on T, it will return 2.5. If I call average 2 on T, that'll also average 2 on T, it'll also return 2.5. However, if I then say something along the lines of 2 of 1,000 equals some big fucking number, oops, sorry, that was bad. T of some really big number equals some really big number, well, really big number, like so. If I use the first one, we'll return the average because that value is really big, right? If I use the second one, it doesn't, because it doesn't consider that really big index to be part of the count, because it's not consecutive. There is not a defined way in Lua on whether or not they're consecutive or not. If I do, for example, I believe, let's try t of 1, 2, 3, 4. Let's try t of 6 equals 3, and I take average 2 of t, I should get nil. Yeah. Because t of 5 is nil, but it considers 6 to be the length of it because I added t of 6 to be a value, even though t of 5 doesn't have a value. Lou is not very good about this. Even if this is what